Okay, so members, today we are going to see now how do we handle now the case 2 when the denominator is quadratic and unfactorizable while the numerator of that integral for it it's a linear function. Here the idea we are going to use this formula here and also the idea of completing squares at the later stage of the number, and so that we can use this substitution. Now why do we use this? We use this so that we can create the function's derivative. Then this constant, we have seen that if you have unfactorizable denominator with the constant up, then you can easily interpret that using the term substitution. That's why we want now to separate this numerator. So the formula here we use is to separate this numerator, as simple as that, using these two things and substitute. So let us get to this number. Interpret this is that now the numerator is linear, because here the function is for x, which is power 1, and this one is quadratic and factorizing. So first of all, we use the formula that our numerator is equal to k1. This k1 and k2 are the constants we need to find. So from here, I'll say now my numerator will be the numerator which is equal to k1. Now, the derivative of the denominator. In addition, this I get 2x plus 4. Solution is we get 2x, solution is we get 4. Then this is 0, then plus k2. Now we need to get these constants. We just compare the coefficients. If you open brackets, it will be now 2k1 x plus 4k1 plus k2. So here we compare. If I compare, you can see that now for x, this side I have the coefficient of x, this side I have 2k1 equaling this side are 4. From there, you can see that 9k1 is equaling to 2. If I compare now for constants, x power 0, the constants, this side I have 4k1, then this is also constant, equaling the constant this side, which is 5. And from there, because your k is 2, this will be 8 to the other side, your k2 will be a negative 3. Now meaning that the whole of this for x plus 5 will be equal to now k1, which is 2 into then k2 is negative 3. Don't simplify, because if you simplify, you are going to get this. Don't simplify from here, just get this and drop it into this formula. So now my integral dx will be now integral, the whole of this numerator is this 2x, then minus 3, then the whole over x squared plus 4x plus 5 with respect to x. Now here we can separate. If I separate, I have now integral 2 into 2x plus 4, the whole over, then minus, this is going to be a constant, okay, 3 dx over the denominator plus 5. So now we have seen how to interpret this case 1 in the last lesson. Then this one, you start, this is the function's derivative. When I differentiate this, I get this. This is dx. So this is the function's derivative. So this will be now 2 into 2x plus 4. If I move this 2 out, dx over x squared plus 4x plus 5, then minus, if I remove this 3 into dx. Now let us complete squares for this number and you see. So my x squared, if I complete squares for this, so now my x squared plus 4x plus 5, it will be, we have seen how we complete squares for this. This will be x squared, then plus 2, a half of this, then minus a half of the coefficient, then plus 5. And this will be x plus 2, the whole squared, so the whole of this is in here. Then this will be minus 4 plus 5, which will be x plus 2 squared, then plus 1. So now we are going to use this. I'm going to write this as 1 plus x plus 2 the whole square. So now this will be 2 natural of x squared plus 4x plus 5, then minus 3. This one you have seen, you get. Now we start here, your a is 1, your b is also 1, using, if you compare these two. So I'll be having now this as tan inverse of x plus 2, because a is 1 and b is 1. So, and now that's a constant of integration. When I come to the second says integral x dx over x squared plus x plus 1. The same idea. Your numerator is equal to k1, the denominator. So my numerator this time is x equal to k1 into derivative of the denominator. When I differentiate this, the denominator, when I differentiate this, I get 2x, then plus a 1. When I differentiate this, I think this I get x plus 1. This will be 0, then plus k2. So from there we expand. We are having 2k1, then plus k1, plus k2. Then we do what? We compare. So for x, this side we have 2k1, the other side we have the coefficient of x as 1. So for x, the constant, we have this side we have, these ones are constants. Plus k2 equaling 2. This side you said is no constant, it's just a 0. So from here, to start your k1 will be a half. If you divide, and if k1 is a half, it means that my k2 will be negative a half. If you put here your k1 and take the side, it will be k2 will be negative a half. Now, meaning that now my x will be a half into then minus 1 over 2 in that order. So don't simplify this. When you simplify this, you are going to get this. So the whole of this come here and you substitute it. So now my integral now this x is this. Then plus integral. Now I'm going to separate at once. This, now this, then this is negative a half dx over. I'm from this step, I come to this. So that's what I'm doing to us. So from here, you see it's a function and its derivative to x plus 1. Then here, if I remove this negative half, I have the x over. Now you complete squares for this. So my x squared plus x plus 1. So coefficient is 1, so I'm good to go. This will be now x squared plus x, then plus a half of the coefficient of x squared. The coefficient is a 1. So a half of it squared, then squared, then plus a 1, which will be now squared, then plus 1. So this will be now then plus a half. So now, if I write this a half here, I'm now set this a half and be the same as x plus a half squared, then plus square root of 1 over 2, the whole square, so that I can express it in this form. So from here, I want to start with this, so root 1 over 2, the whole square, then plus So this will be natural log. Start reducing this, you get this. So this will be natural log. Then minus a half into, now from here, you can start 9a is 1 over root 2, then 9b is 1. So if I say a times this, I'll be having 1 over root 2 times 1. Then tan inverse of 1 over root 2 plus c. Which you can easily simplify to, this will be a half now. Then minus, the reciprocal of this will be now root 2 over 2, this 2 will go down. Then tan inverse of over 1 if you want. Then plus our constant of a expression. So members, that's how we handle those numbers. If it's the coefficient not 1, you can see how we handle those videos in the last lesson. Don't forget to subscribe to the channel. I wish you the best.